Hi, welcome back. I'm Jadi and you are finishing LPIC 1. Good for you. What is this? This is known still bad. Now it's good. We've reached to the last session or module of the LPIC 1. I will speak in 3 different videos for this section, securing data with encryption. Very fun, one of my expertise, and I really enjoy it. The weight is 4, it used to be 3, but security is becoming more and more important. You should have a good understanding of OpenSSH, encryption, public key encryption, asymmetric password, GNOPG, GPG, and SSH tunnels, which is very, very fun. But let's start talking about encryption and key pairs. In the old times, and even now, many of us use symmetric encryption. That's just like your home. You have a key which opens the door of your home. This is one key. If any friend of you wants to enter your key, your partner gets a key, you duplicate the exact same key and it works. If you lock your home with this key, the other person will open it with the exact same key. Sometimes we create zip files to secure our data and encrypt it with a password. You should share the exact same password with the person who wants to be able to open this zip file. This is symmetric encryption, cryptography. You have one password. You use it to encrypt and decrypt. You should share this password with whoever wants to be able to decrypt the file. You have to share the exact key with whoever wants to be able to enter your house. This works but has lots of problems. For example, if you are a system admin and you want to let a person work on your server, you should share the password with the first person. With the second person, third person, all of these people do have the password. Then this guy shouldn't be able to log in anymore. You have to change the password and inform everyone. Ugly. Or create lots of users, and that will make problems because sometimes they want to work on an exact same implementation, for example, of a software. That's why in 1976, some mathematicians, geniuses, invented asymmetric keys, asymmetric encryption, asymmetric cryptography, or the public and private keys. Just think about it like 2 different keys which are related to each other. One is private, one is public. Whatever you lock with the private key can only be opened using public key, and vice versa. This is so cool. What can you do with this? You can say, I create 2 keys, the private key and the public key. I will publish my public key on the whole internet. Everyone has it. If anyone wants to send me something private, it's enough for them to download my public key, encrypt whatever they want using my public key, put it on the internet. Anyone can see the encrypted data. So, who can open it? Only the person with the private key. And I am the person with the private. Everyone can download this encrypted data, but no one can open it except me. The genius behind this is you don't need a secure channel anywhere. You don't need to secure your channel. On the symmetric keys, you have to go and whisper in someone's ear, this is our password, don't tell anyone. But here, practically, you can shout anything and nothing bad will happen. You cannot shout about your private key because you don't need to. You can shout about this. But when you want to speak with someone securely, you don't need a secure channel. This is the genius behind this. You can just publish your public key anywhere and have your private key with you. They can encrypt data with this and publish it on the whole internet, and only you can download and decrypt it. This is super nice. This is called key pairs, because you make pairs of key. This is what is used in SSH server to have keys, and you will communicate with the keys. The whole communication will be encrypted. Same thing on TLS, on SSL, and other protocols. Practically most of the communications in the current world on the internet, the secure ones, which are most of the communications, are being done over these concepts. And the key pairs, asymmetric encryption, and these kind of stuff. This is so cool. Same thing happens for SSH. Oh, I've tried to SSH. My SSH client contacted SSH server on that server. And that server said, okay, welcome. My key using this protocol, ED25510, with this fingerprint. It doesn't show me all the public key because that would be larger. It creates a fingerprint of that. If I'm paranoid or if I'm sane, I would contact the administrator of the server and will ask if their fingerprint is this. We don't do this most of the time, and most of the admins won't know about their fingerprint. They can check it or they can search and learn about it. But if you want to make sure that you are speaking securely with the server, first time you have to check this. If this is the same, you may call her and ask, oh, Sarah, is this your fingerprint? Says, my fingerprint? Oh, your server's fingerprint. Oh, yes. Then you will check, okay, it starts with 4WP and ends in 09U, all capital, except the P. And she says, yes, that is fine. If you are super paranoid, you have to check every single letter, because people can forge keys with this easily. It's random, and it means only create a few million keys, and one of them will have the same start and end, but not in the middle. So it's good to check all of them if you are really want to keep yourself safe. But here I said SSH to this one. This was the first time I was SSHing to the server. So the server told me that this is my key. My client said, this is the first time I'm seeing this. Do you agree that this is the key algorithm and this is the fingerprint? I would say, yes, this is okay. The client says, no, please type yes. I want to make sure that you understand what you are doing. I said yes. And this says, I permanently added this. And the connection is gone because it took too long. If I do an SSH next time, it's not asking about the fingerprint anymore, because it says, okay, after you said yes, I permanently added this host with this key to the list of known hosts. Now my computer knows that the fingerprint of the key for this server is this. This happens every time you log in into a server. I'm back in my computer, but where permanently? Everything happens in .ssh directory. I have a file which is called known hosts. I'll go to the end, and here you can see that those datas are here. That's why my computer knows that this server is legit the next time I try to log in into it. If the fingerprint of the server is changed for any reason, that would be a huge offense, because you used to connect to the server with this fingerprint. Next time, if you are going to this server with another fingerprint, maybe someone is doing a man in the middle attack. Someone maybe eavesdropping you, listening to things, or maybe this server is gone and another fake server, this is the one you are connecting to and checking what password you are going to provide, so we'll know your password for that user. That's why seeing that this is changed is a huge offense. It's not difficult, but I prefer not to change the keys on that server because that would confuse you. Instead, I can do an edit here and says, okay, we had this, I will change one letter here. So my known host is changed. I'm just changing one letter on each line. Now the fingerprint, what I have is different than what server provides. If I try to connect, it doesn't even ask anything. It says remote host identification has changed. It is possible that someone is doing something nasty. Oh, I've got this from the server, but you have something else in your known hosts. And it doesn't even let me to try to log in. Please note. If you want to fix this, sometimes this happens, especially on the sites with the form of the IPs we use in the networks, in private networks, in homes, because maybe I have this server somewhere, maybe I delete it someday, create another server on another network, someone is using the same IP or whatever. If you want to remove this, you can edit this known hosts. Everything is in .ssh in your home because these are my configurations, and remove those lines for that IP address, which is not very easy. You may do mistakes. So there is a command for this. You can do, here I have it, ssh-keygen. This is mainly used for generating keys, but I can say remove 192.168.72 from known host. Now it is removed, and if I do an SSH, there is nothing in the known host. It will ask me, is this fingerprint okay? I will say yes, and will ask me the password. I will log in. If I exit, SSH once more, no question, because now it has the correct one in the known hosts. So this is how this works. Was it fun? Yes, for sure. Keys are fun. Okay, since we talked about keygen, in this case I used it to remove a key from my known hosts, but you can use it to create your own keys. You may need keys for different things, remote SSH or whatever. If you want to create a key, just run the ssh-keygen. We are talking about SSH commands. ssh-keygen will create a key for you. Normally, it asks you where it should create it. I haven't gave it any parameters, so by default it is creating a RSA key, the beginning initials of the names of the 3 people, geniuses who invented this. So by default it's creating an RSA key. It says, what should I call this key? This is the default name, ID RSA. I say, okay, this is good. It says you already have a key. I said, okay, overwrite it, no problem. Do you want a passphrase for this key? No. If I create a passphrase, each time I'm using this key, I should provide this password. So it created one .ssh ID RSA, which is the private one, and one .ssh ID RSA pub, which is the public one. And also showed me the fingerprint, also relevant. It's called random art image. It's an image related to this key. So later, if I want to check if this key is changed or something, I can compare this image with that key's image. But these are totally different. If one bit is changed, totally different image. So it's easy to see in one glance if these are the same or not. Man, ssh-keygen. I'm looking for -t is here. -t. These are the different algorithms you can choose for your key generation. DSA is the older one. Now it's completely obsolete, shouldn't be used. ECDSA is a good one. ECDSA SK is a related one to this one. This is another one, even newer one, better than this. And RSA is the default. This is what Bitcoin uses for its encryption. Elliptic curve, I don't know, blah, blah. So, if I wanted to create a specific one, I could say ssh-keygen, and I want this kind of keys with dash T. It would ask me, I would call it ID, this one by default, good, no passphrase, and it is created. Again, one file is called .ssh. This is the private one, and another one is called this, but the public one. Please note, for no reason in the whole world, at least the one which I can think of, you should not give anyone your private key. There are some phishings. They would say, okay, I'm creating a server for you. It's a 1 week free. Please send this file so I will add your key there. Never do this. You can only share things which has the extension of pub or public. The other one is the private one. In the LPIC, it is requested that you know about these different files. .ssh, ID RSA, and ID RSA pub. The private one and public one for the RSA keys. ID DSA for DSA keys which are obsolete, and ID DSA pub. ECDSA and ECDSA pub. ED 25510 and blah 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 dot pub. So these are different protocols for the keys. And remember, we were creating this with the Jadi's username, and the results were being saved in Jadi.ssh key. These are my keys. The system-wide keys for SSH connections and other stuff are located in /ssh. Same thing. The key, the public key. The key, the private one, the public. Sorry, this is the private one, this is the public, and this and others, which is where is the equivalent of this one here. So, pair of keys. The one without the extension is the private one. The one with the public is public one. These are what SSH is using. I created keys for myself, my own. It's free and you can create as much as you want. But why this is important and where this is used? One of the big usages on private keys on SSH is passwordless logins. Whenever I did SSH to a server or user at a server, I had to provide this user's password. This is problematic because remembering password is difficult. You write it somewhere, it's not safe. Or if you are using a script, a CPing, which is working with SSH, a CPing a file somewhere, you should provide password so you cannot use it in a script safely. Or if you are a system admin and a new person is going to work on your project for 1 week, you have to share the password with him and then change the password. If there are 10 people working and this one is not going to work anymore, you have to change password, inform everyone, all other problems. So one good method in SSH is key-based login. You can configure, and most of SSH servers are pre-configured, to be able to log in with private keys. Again, system admin will ask you for your key. You always send your public key. The system admin will add your public key to SSH configuration of that specific user. And whenever you SSH to that machine, the SSH will say, okay, you can log in with password if you want, provide password. Or you can log in with a key. And for sure, it will ask for the key first. It says, I have these public keys. Do you want to use any of them? You say, yes, I have a private key for that specific public key you have. And it says, okay, if this is true, please encrypt this string for me. Your machine, your SSH client will have access to this, will encrypt this string using the private key. The server will check it with public key and says, okay, you were able to encrypt it. So you have the private key. So please come in without password. This is super cool. If you want to do that, let's do it manually. I will go to my SSH. I have different files here. I will share with you my, for example, public key. You can show your public key to anyone. RSA public, but no one should touch your privates. Important. Unless you give them permission. But in encryption, no one. I will copy this. So I have my ID RSA pub. I will connect to the other server. My password. I will go to the SSH directory. There is a file here, or if it's not, I can create it. It's called authorized keys. I will edit it. And I will add my private key here. My public key here. I added my public key to jodis.ssh. If I exit and try to SSH once more, you are in without the password. This is very convenient and very easy. People do this all the time. We do this every day on our servers because we don't want to type passwords all the time. You can also try with -v to see what SSH is doing. You can see all the logs. Somewhere it says is known. I know this host and it matches the host key I have in authorized keys. Sorry, in known host. This is the line. So let's go forward. Open SSH blah blah somewhere. It says, okay, you can continue with these methods of authentications. Public key or password. So I will try public key. I'm offering my public key. This is my public key. I'm offering this. Server accepted this key. Cool. So it's done. I'm using public key and I'm logged in. Nice. So as you saw, I offered my public key. It accepted it. It didn't start it by saying, I accept these keys. So this is the passwordless. But copying this, editing manually is prone to errors. You may make mistakes. So there is a command which SSH copy ID. I can say copy my ID to this server. It says, okay, I copied your ID because I had passwordless login. It just copied the IDs, whatever it found. If I didn't have passwordless login already, it would ask for my password. But what this SSH copy ID did on my machine was it went, it checked the keys I have, contacted there and said, please copy this public key to your authorized keys. And it is done. In my own experience, this sometimes makes more problem because you are not sure which key is copied. You have to check it then. I prefer to do it manually, but be cautious not to break the files. And please also remember, on this machine, etc ssh config, the configurations of the SSH should have this login. PubKey. Should the configuration of the SSH server should have this PubKey authentication? Yes. This lets public key authentication in addition to the password. If you don't have this, this won't work. Although most servers do have this at the moment. And at the end, I have to speak about SSH agents. When we were creating our key using ssh-keygen, we didn't provide any password. If we did, every single time you needed to use this key, you had to provide a password, which practically is against the whole idea of passwordless login. So there is a program ssh-agent. When you run this, you run it like this, and you say ssh-agent start a shell, and then ssh add. It adds all the keys to this agent. This agent keeps all the keys in your memory. So whenever you log in for the first time, it will ask for the password. Then it has the passwords in the memory and just enters them whenever needed. This is the main usage of the SSH agent. Another important usage is the transfer the keys. If you have one server in many companies, if you are working, there are different servers which are running programs, and there is a jump server. You connect to this one only. These are not accessible from the internet, and then you connect to any of these. If you have your SSH key configured here, okay, you can log in here. But you have your SSH keys here too, your public keys, and you want to be able to log into these, but your SSH private is here. So you have to copy your private here? No. You never move your private keys anywhere because other people might have access and do have access to the jump server. So you use SSH agent as described, and you will have your keys in memory. So when you SSH to this machine, SSH agent will transfer your keys here. Then when you jump here, the same keys will be used. This is why it is important. Hope you enjoyed it. It's a deeper look. Whenever you have a problem with SSH, always try SSH-V. It will show you lots of interesting information. Even when you want to learn something, try this V and you will know more about the internals. I will go to the next section. We'll talk about SSH tunnels, which is also super cool.